Let me get the microphone on here. Hopefully you can hear me. Okay, this was problem 29. I still had some things I needed to show you with respect to this. This is the one where we have the Toyota coming from the traveling east, and the Bonneville Pontiac traveling north, and they are moving toward an intersection, and part of the problem was to figure out the distance between the two cars at any given point in time. So we did figure out an equation for that, which I'll go ahead and put in the menu here. Now we're not doing this as a parametric equation yet. It's just the distance equation, distance in terms of t. So we'll go ahead and put that in. It's kind of a long problem. It's the square root of 40t, and t in this case is x for us, minus 5 squared plus 30t minus 4. Squared, and then we just shut off the square root. So that should be the formula, and then we have to graph it. And the trickiest thing I found about it was figuring out what the window should be. So initially I did it as zoom fit just to see what we got. So you can kind of see the thing coming down a little past the y-axis. It reaches a bottom point. Actually, this point on the y-axis would be when the when the Toyota's 5 miles away from the intersection, and the Pontiac is 4 miles away from the intersection, because that's where we have our t equals 0 position set. So anyway, why don't we go ahead and just use zoom box to shave off a part of this that will be helpful to us. So why don't we begin it there? I don't know how far we really need to go out. Okay. Okay, well, we can't really see the bottom of the y-axis, so we might need to make a couple adjustments here. X min, X max. I think, it's an hour, so going out to 1 hour really isn't so unusual here, so we'll just have it be 1. And y min, we have to have y min at least at 0, so why don't we make this like -5, and y max, no, probably 30 would be good enough, and we'll have it go in steps of 10. Okay, let's graph that. Well, again, that's not as great as we'd like it to be, because we really can't see the minimum point that well. It's a little better than it was, but I'm going to go ahead and do zoom box one more time and just get that part of the equation we need where it goes down to 0. Okay. So that looks like it'll be good. Okay, yeah, that's a lot better. So why don't I go ahead and take a screenshot of that? Well, we'll go ahead and determine the minimum first. So we'll go to Calc, minimum, and that can be our left bound. That's fine. And we'll put our right bound there, and then we'll just back up a little bit and find out where that point is. Okay, so that shows us that our minimum is a 0.12799, etc. And we had determined our the cars to be at a minimum at t equals 0.128 hours, which is basically what that is. And we also have the minimum distance being at 0.2 miles, which is what that shows. So this gives us the answer we were looking for. So we'll go ahead and take a screenshot of that. And this will be, what is it, problem 29. And that's part B of the problem. Okay, the next thing they wanted you to do, and I'll just go ahead and reset the calculator. The next thing they wanted you to do was graph these equations, the parametric equations we determined in part A of the problem. Determine those, or actually I guess that might not have been part A, maybe that was part E, or part D it looks like. So graph those parametric equations simultaneously, and so we should be able to see the two cars approaching one another and what they do. So there's a few settings you have to make this work, but which is kind of tedious, but it's best to show it on here so that you can see everything that's being done rather. Okay, the first thing you got to do is make sure you're in parametric mode. And also, we want to graph the equations not sequentially but simultaneously, because we want to see both cars moving at the same time. So those are two important things you have to do first. Then we enter our functions, and the first function for the Toyota was, let me see, x equal 40t minus 5, so 40t minus 5, and y equals 0. It doesn't have any y motion because it's moving to the east. And then the other one was the Pontiac. That was, let me see, that was y equals 30t minus 4. And in this case, x is 0 because it doesn't have any, or rather, y is 0. Oh, wait a minute. Did I enter that? Oh, I entered that improperly. Okay, clear that. X is supposed to be 0 here, and y is supposed to be 30t minus 4. Okay, and that makes sense because it's just moving along the y-axis. So the next thing we need to be sure that we have going here is we need to make these be with the little circles there. That's kind of weird. I wonder why one has a little negative in front of it and one doesn't. I'm not quite sure what that means. But I've always used the negative one. Oh, okay, what that is, I guess it draws the line along with the circle, which is what we want. Okay, so we want that. And then the last thing we need to do, we need to go to the Format menu, and we want to turn our axes off. And they wanted to do that because our cars are moving along the axes, and if we have the axes there, we won't be able to see the actual motion that the cars make that well. So we'll go ahead and turn the axes off. Okay, the very, very final thing is figuring out what the window is. So for time, why don't we go to like a half an hour? I think both cars are through before a half an hour is up. And we'll make the step, why don't we make this 0.01, have it move kind of slowly at first. We can always speed it up later if we have to. Okay, Xmin and Xmax, probably we ought to be out, I don't know, maybe 5.5 miles, negative 5.5 miles to 5.5 miles. That's how far the thing, because it's at 5 miles to the west when the whole thing starts. So we're going to go 5.5, and we'll also go out 5.5 for Xmax. And the scales along the x-axis, oh geez, I don't know what to do. Oh, we don't really even have axes, so it doesn't matter what we have there. Okay, Ymin and Ymax, similarly, we're at 4 miles to the south when the whole thing starts, so let's go out 4.5. So we'll go negative 4.5 and positive 4.5. And again, the scaling doesn't matter because we don't have axes shown for our case. So this should show it. You ought to be able to see the cars moving and whether they crash or when they pass through the intersecting point and all that. So we'll go ahead and do that. Okay, yeah, so it looked like the Toyota passed through the intersection before the Pontiac did. The Toyota was coming along this one. It looks like it went through first, and then the Pontiac came up and went again. So let me shave a little bit. Maybe we can make this like 0.25. Don't have it running quite so long. So we'll do it one more time. So you see the Toyota coming here. It passes the intersection first, and then this guy goes up. So that's pretty good. Let's just run it one more time and take a screenshot. Hang on, that wasn't right. We want to go to draw, and then clear draw, and run it again. Okay. And graph. take a screenshot about there. That's reasonable, I suppose. And this is problem 29, and this was part E of the problem. Okay, and there they go on their way, and you see that they never actually do crash into each other, which I guess is good.